Hello, everyone, and welcome to this Telit Cinterion webinar, Cellular Connectivity and Antenna Design for Asset Tracking. I'm Amanda Flink, the Head of Global Events here at Telit Cinterion, and I will be moderating today's event. I want to start by thanking Ignion for joining us today. We really appreciate you guys being here. Let's quickly get to know our speakers. To explain this topic today, I am pleased to be joined by Stefan Marr, Regional Product Marketing Manager at Telit Cinterion, and by Lubna El-Mahdi, a Lead Engineering Antenna Engineer at Ignion. Now, just before I hand it over to Stefan to start our presentation, I do have just a few quick reminders for our audience. We'll have time to answer some questions at the end of the presentation. You can simply submit a question by posting in that questions box that's located near the bottom of your screen here. Also, please be sure to check out the resources section for some additional information on our topic today. There you can find a few resources that will be referenced in today's presentation. And finally, we will send out this replay link to all attendees at the conclusion of the webinar. And Stefan, with that, I will hand it to you to start our presentation.
So thank you, Amanda. Good morning or good afternoon to everyone from my side. Today, I'd like to talk about the growing asset tracking segment and what we, Telit Cinterion, can offer to this industry. The growth here is mainly driven by the increasing demand and regulations to track all type of goods. So one example is the food supply chain. Another example is the pharmaceutical industry that needs to track the medicines, as we've seen with COVID vaccines recently. So as more and more valuable and critical goods are, as more we want to monitor them and in every location and in all times. So Berg Insight, a leading IoT market analyst, has released some quite interesting market reports. Just some figures here on this slide. The first one on the left shows a forecast of the cargo container tracking market. The installed base of tracking devices will grow at 18% per year, from 8 million units in 22 up to 20 million in 27. The second report on the right, it covers the cold chain tracking market. So the installed base of active tracking devices there will grow at 13% per year from 2.4 million in 22 to 4.4 in 27. The number of active trackers and real-time data loggers for these general cold cargo reached 1.6 million units in 22 and will reach 5.2 in 27. So this leaves a nice growing market and by that good business for all of us. Because with asset tracking segment growing, we see a similar growth for the IoT connectivity. So here, a quick view on the infrastructure for tracking. The diagram here on the left explains the four main building blocks of an asset tracking solution: the service segment, the network, the positioning, and the device segment. Today, we will focus mainly on the device segment. So inside the device, you have two key components, the connectivity module or modem and the antenna, the RF antenna. We will hear more about this antenna part in the second part of today's webinar. Of course, in order to build an end-to-end asset tracking solution, you need to focus to more than just of this device. The network segment consists mainly of a cellular network to exchange data with the cloud, recently including end-to-end satellite communication within latest 5G standards. The positioning segment provides location information with high accuracy, better than a few meters with the GNSS. But also worth mentioning here are positioning services based on Wi-Fi access points and cellular base stations. The readout of cell IDs and the signal strengths combined with location data of these points in a database provides accuracy down to a 50-meter range. It's of course less than any GNSS for sure, but the advantage is it works also deep indoor and it helps to accelerate the first time to fix of GNSS. So last but not least, the service segment. This is where you collect and monitor the information, what's going on in the field, and manage your tracked assets. So on the right corner of this slide, you see a few different use cases for trackers. Here, bicycle trackers, trackers for vehicles or boats, or either to monitor performance of the vehicle or monitor driver's behavior for usage-based insurance, and many, many other use cases. So with this, let's take a quick look on the main challenges for kind of companies who create products and services for these tracking use cases. So I'm starting from the top left corner here. So they need to bring up high quantities of devices in stock before the revenue gets in and they handle the high investments ahead. The cellular module is a core component of the device and it's a big part of the BOM cost. They often need recurring revenue from subscription to pay device costs over the service period. They need to handle a dynamic business model. They need to add and remove devices to the network. They need to organize functional groups and adapt billing rules during the lifetime. And battery saving and power constraints require an efficient RF and application design and a smart power saving in the cellular device. Within that, also the amount of transmitted data need to be monitored and reduced as much as possible. These devices, they send critical data. They need secure, resilient connectivity via multiple MNOs in different countries, inclusive roaming in restricted markets. Of course, they need a robust GNSS positioning as well. And they need to handle global rollouts that requires a trusted partner for connectivity and support to prevent issues and prevent reputation loss in case of issues. So here, to give a quick view about the solutions we offer to support the business of these tracking providers. In addition to our cellular modules portfolio, we provide connectivity. We call it Next, is the brand. And we are a global IoT MVNO here. So trackers, they need SIMs and connectivity across all regions with predictable, reasonable, and cost-optimized tariffs. We can provide those SIM cards that connect to cellular networks all around the globe, everywhere your device is traveling to. As well, you need a remote management tool that allows to monitor your fleet of devices in the field. Telit's One Edge platform, it's a customizable platform, can be the perfect solution for this. Among this, I'd like to mention our new interesting offering. It's called Connected Module as a Service, where we offer module, connectivity, and the management tools sold together as one, all delivered under one contract with a monthly subscription fee. So the benefits here are there are one price for the complete package with attractive commercial terms. So it's a good way to lower these high investments for hardware and in the beginning and shift it to later while the service period. You have one partner for service and support, and you get one management platform for full control of your devices. So now let's look inside an IoT tracker in the device. So here you see two typical architectures of such a device. On the top, you have something we call a hosted architecture. So next to the communication module, you have a host board with an extra processor that is running the tracking application. The cellular module is only used as a modem to transmit and receive data, but the logic runs on a separate processor of the tracking device. So on the lower part, you see a hostless architecture. That's a good way to get rid of these extra CPU. So here, all the logic and intelligence is running on the module. We offer an environment to run the application software on Telit modules. This is called IoT App Zone. And it's starting from a small real-time operating system with a C language. It goes up to smart modules with full Linux and Android environment. Sensors, memory, power, and SIM, they are all connected directly to the module here. So often this hostless architecture may be the more optimized way. It makes a better use of the resources of a cellular module, and it brings down costs, size, and lowers the power consumption in some use cases. So with that, let me name the main points for cellular modules in trackers. First, to ensure the module supports the right frequency bands for global or regional tracking and select a global or regional variant. They are available with eSIM, also embedded SIM, or iSIM, a software integrated SIM, as an option. For continuous GNSS positioning, you select a module with embedded and concurrent GNSS. So concurrent means here GNSS reception while cellular transmitting. Also, you may use additional features for location services based on Wi-Fi and cell locate, as I mentioned before. For secure, resilient, and power-efficient connectivity, you choose the best fitting cellular technology available in your region. It's important to understand these differences between these technologies and standards. So you see values of cellular standards LTE Cat1, Cat1 bis, and Cat-M on the lower part of the slide, as they are widely used by asset trackers. Cat1 bis compared to Cat1. So LTE Cat1 bis allows designs with one single antenna and lower costs with that, versus the dual antenna on Cat1, therefore with a little more RF performance. Cat1 bis compared to LTE Cat-M. Cat1 has a higher data rate, it's clear. There is a greater coverage with Cat1. It's deployed almost worldwide. Some Cat1 bis chipsets support voice or VoLTE in many parts of the world, but still not available in the US by today. While LTE Cat-M, this is a 5G ready technology with the longest lifespan from today's perspective. So Cat-M has lower power consumption versus Cat1. And Cat-M is very strong in North America, while it's still fragmented in some other countries. So there's no technology better than one other. It depends on the detailed use case and the region. So what we just discussed, both Cat-M and LTE Cat1 are good choices for trackers. And most of the devices going to use this standard, as you see here in the middle of the slide. But there are other options with different data throughput, with different latency, also different reaction time in the network, and with different power consumptions. NB-IoT, for example, you may pick as the lowest tier option here. It's maybe good for simple, low-cost, small battery-operated asset trackers with limited mobility. LTE Cat 4 on the other side could be an option if you have advanced audio and video functions connected to this tracker. So, for example, to listen in or to see in your container or track device and send large files to the cloud. Let me also comment on the bubble on top of Cat 4. You see here 5G RedCap. There's a 5G version called RedCap for reduced capability, and that will play an important role over the next few years. It will fit for some tracking use cases, both in terms of performance and future evolution of cellular technology. But if someone considers RedCap standard for tracking today, it's mainly due to enhanced longevity of their devices only. So with this, I'd like to show some questions we ask our customers to make the right module selection before they start designing their tracking project. For example, is your device okay with low or medium data speeds? Then you don't need Cat 4, don't need a RedCap. You probably are good with LTE Cat 1 or Cat 1 bis or even Cat M. You don't need migration paths. Yeah, you do need migration paths for legacy technologies. Then we offer compatible modules across multiple technologies in the same footprint. Customers need easy evolution if they need to upgrade from 2G, 3G to 4G, and then even to 5G RedCap later. So I'd like to give a quick view here on the two of our main product families. You see this on the right side, the 910 family, compatible product from NB-IoT up to 5G RedCap global versions. These are more than 100 million units shipped worldwide since the days of 2G. It's a de facto standard in the industry, best in class in thermal and best in class in RF performance. And then the small 310 family, ultra compact global and regional variants from also NB-IoT to 5G, future 5G machine type communication standards. LTE Cat 1 bis will be coming soon in this family as well, with a next gen chipset for very size constrained use cases. Another question, you need full mobility for vehicle tracking? Then NB-IoT may not be an option. You need to focus more on Cat M or Cat 1. Is your application battery powered or attached to the main power? Important, if battery powered, you need to look at the module power consumption, but if attached to the power of the host, for example, a truck battery, then you have far less restrictions here for sure. You need multi-region coverage and roaming. This is important for the module and the connectivity provider. LTE Cat 1 gives, of course, the most or best option here. Also choose wisely the connectivity provider. We, as Telit, love to be a partner here. You need lifecycle compatibility with low power consumption designs. Then you may choose Cat M or even a RedCap from a longevity viewpoint for these low power designs or lowest power designs. And of course, make sure whatever module you pick, it supports firmware upgrade over the air or FOTA. Often this is mandatory. One reason is for insurance in case something goes wrong, but also in case of making your application future-proof or give you and your customer the option to offer new features. Of course, our modules, they are all capable for firmware over-the-air upgrade. This is clear. So far for now from my side, I'd like to hand over to my colleague. She will inform us about important points in the RF and antenna for tracking devices.
Thanks, Stefan, for your presentation, and thanks everyone for joining. This is Lumna, and as Amanda mentioned, I'm an antenna engineer at Ignion. Currently, I am leading the EMEA region, helping the customers in all the phases of a product of a device. So I've been involved in lots of customer projects, from a smart meter to a pet tracker. So today I want to reflect this experience into this presentation from a technical point of view. Okay, so imagine yourself, you are designing an asset tracker for a container tracker, a metallic container, sorry. We know that nowadays the number of devices connected are increasing day per day. So all these devices integrate an antenna, and this antenna needs to face some challenges that we need to take into account from the very beginning of a project. So as I mentioned, imagine we are dealing with a tracker that will be traveling all around the world. So we need to take into account that this tracker will be covering a multi-band because of the different regions of the world. Also, it's not the same having the tracker in the middle of the city or in the middle of the sea. So we need also to take into account these environmental impacts. And of course, the coupling effects. We will be dealing with other antennas. And last but not least, the battery efficiency. If we don't have battery in the device will not work. So there are some challenges that we need to face to let everything work properly. And you might ask yourself how the virtual antenna can help on facing all these challenges. So let me explain you a little bit what is a virtual antenna component. Okay, so a virtual antenna, we can say that is a system composed by the virtual antenna, the matching network, and the ground plane. Our technology, our antenna, uses the ground plane to radiate, and the matching network tunes the response of the antenna into the desired frequency bands. So imagine we are working with a 50 by 50 PCB with the same antenna, same matching, and same ground plane dimensions. So we can use the same design for GNSS and for Bluetooth. We just need to tune the matching to the desired frequency bands. The main objective at Ignion, our main objective is to make easy this process of antenna integration, because we know that sometimes might sound complex, all these antenna integration topics. So all during these years, we have been working on developing tools to make that process easy. And then we came up with Oxion. That is our new platform. Actually, we have launched 1 month ago. It's a platform based on AI and machine learning that by just typing some basic information about the design, we can have a feasibility report of the product. So we will be saving a lot of time, human resources, because of course you can use it even despite you are not an RF engineer. So it's a very powerful tool that will enable us to move forward to the design stage. As I mentioned, we want to make our antenna easy to integrate. So with Oxion, we have the phase 1 of our design journey complete. So once we have this first stage complete, we move to the design, where we check the Gerbers, and once we have the green light for the Gerbers, we can move to the prototype, where we can tune the matching network to the desired frequency bands. It's true that sometimes it's for complicated designs, maybe we can run a more difficult, let's say, 3D simulations. But for a regular PCB, regular project, we can move directly from feasibility to Gerber check and prototype. And the last stage would be the certification. And as I said, we want to make the things easy. And if we follow the design path, we will have our product, let's say, complete. But it's true that we have seen based in our experience, based in the projects we see in our lab, that there are some common mistakes that if we avoid, we can improve considerably the antenna performance. Of course, the antenna location is very important. This antenna location is set in the phase 1, in the feasibility. So once we have the antenna location established, we can set its clearance area. So the clearance area is a very important concept because that makes the difference on having a very good design or a not that good design. So the clearance area is an area free of any kind, any type of metal. When I say metal, I say batteries, screws, metal casings, anything that can affect to the radiation of the antenna. Okay, so if we can avoid these points, you will see that the performance will be higher compared that if we do it. And of course, as I mentioned in one of the first slides, it's very important to consider the ground plane dimensions. At the end, our antenna radiates through the ground plane. So as higher is the PCB dimensions, higher will be the performance. But you can say, Luna, but how I can find the balance between PCB dimensions and efficiency? Because if you see in the graph, as higher is the dimension of the PCB, you see higher performance. So the good thing here, now it's a very easy step that you can do it by yourself by using the AI Design Explorer. That is a very powerful tool included in the Oxion platform that by just drag and drop the tabs we have here, we can see in real time how the efficiency is being impacted. So if we decrease the clearance area, we see how the efficiency decreases in the graph. So by doing this exercise, we can see in an easy way how the performance varies depending on these 3 parameters: antenna location, clearance area, and ground plane size. Okay, so of course, not all the designs are that easy or that simple. Our technology is also able to manage with small form factor boards that maybe can introduce a little bit more of complexity. It's not the same or having the same one antenna or 2 or 3 antennas in the same board. So the good thing of our technology is as we can manage, as we can tune the antenna response, we can also manage, we can also face the coupling of the antennas, because as we know, the antennas can affect each other. So if we can manage this coupling, we will be increasing considerably the performance. That at the end, what we want is to get as maximum antenna efficiency as possible. Another parameter, another thing that is very important having in mind when we are designing a new product is the battery life. We know that the antenna is directly linked to the battery life. If our antenna is perfectly tuned, perfectly designed, we will see how the battery life will stay longer compared if we are not improved, we are not tuned properly our design. At the end, the antenna is an element that receives and transmits power. So if this channel is not properly integrated, we will see how the battery runs out very quickly. And link it with the battery life, we have one concept called time to first fix that measures the GNSS device signal acquisition time. What does it mean? When we have a tracker in the middle of the sea, this tracker will be searching satellite signals. So this time on linking the device with a satellite is the time to first fix. So if we can avoid spending a lot of time in this mode, we will be also saving a lot of battery. And that is a very important point. And another good practice to follow is to know where our device is going to work. For example, our asset, our tracker. If we know from the very beginning that our tracker will be mounted on a metallic container, it's important to let the antenna know that the antenna will be facing this metal impact. So we can also, through the matching network, face this shifting, this degradation of the signal by the tuning process. It's true that the metal for the antennas, it's like the kryptonite, but we can somehow deal this impact. We know, as you can see in these graphs, that it's not the same having a piece of wood or having the human or animal body impact. So very important. The material also affects to the antenna response. So if we can follow all these best practices I've been mentioning, and we focus our antenna on the transmission bands, it will be very easy to certificate. At the end, most of the products are meant to be commercialized, so we need to surpass the certifications. Ignion is not a certifier house, but we help our customers to surpass these exams. So we always recommend follow our recommendations. At the end, we are dealing with physics, and we are doing as best as we can. And of course, if you want more information regarding the asset tracking, please feel free to scan the QR code, and you will find much more information about how to design an asset tracking. And please let me insist on using Oxion. Please try it, because Oxion is the ChatGPT for RF world. You will see how it can easy your life when it comes to a new design, a new device. So please feel free to use it. And this is everything from my side. Thank you very much for joining. And if you have any questions, please feel free to ask.
Great, thank you, Lubna. And let me ask Stefan as well to join me back on camera here, so that we can go through some questions. Perfect, guys, thanks. Now, before we get to our questions, audience, I am going to drop a poll on your screen here. If you would like to have any of our experts contact you directly, please just respond here on the poll and we will have someone reach out to you. As we said, we have just a few minutes for some questions. Also, there's still time to ask a question, so please submit using the box near the bottom of your screen. And let's just get started with some of these that we've got. Lubna, I'm going to start with you because it looks like we have a couple questions on the Oxion platform. The first question I have here, what are the limitations of the platform in terms of usability? Can I use it as many times as I want for a project?
Okay, yeah, Oxion now is meant to be used on the feasibility phase. Okay, it's limited to say in this way. So you cannot maybe use it for the design phase, but at the end for the feasibility, to use it in the most important part of the on design plan, you can use it, and you can use it as many times as you want.
Perfect. And then it looks like one more question on the platform. Can it give me final matching network for my physical prototype?
Yeah, it can. Actually, the Oxion report gives you the antenna location, the perfect PCB dimensions, and also the matching network components. Of course, maybe if you use those components in a final design, you will see that the response is not the same, because at the end, your device will be including a casing, a battery, or any other components. But if you follow all the Oxion recommendations, you will see that the matching will work in your bare PCB.
Great, thank you. Stefan, we have a module question here. When are RedCap modules available and when will they be used in tracking devices? Oh, sorry, Stefan, it looks like you're muted here.
Sorry for that. So of course, LTE is the standard for today, and it will be also it's future proof. But we will offer hardware and software compatible products for the LTE RedCap standard in the 910 form factor. The samples, they will be available in Q3, and SOP start of production end of 24, begin 25. But the main reason if someone uses RedCap now for tracking is only very long longevity requirements of devices. But we will have it. We will have it in this proven form factor.
Perfect, thank you. Stefan, maybe another question for you. There are new requirements for RED approval on cybersecurity in the EU. Can you tell us how this is affecting tracking and telematic devices?
Yeah, this is in the EU. This is yes, it will affect. It's mandatory from August 25. It got shifted 1 year. So manufacturers need to ensure that personal privacy and location data are secured. So any RED approval is not possible by today, as these harmonized standards, they are not available. It is planned to be available by within the second half of this year. But in general, we see with the changing geopolitical situation, we see a lot more focus of security from our customers here. And we, as Telit Cinterion, ensure, of course, that our products and our modules, and by that our customers' devices, will comply with the RED cybersecurity requirements as well, and in time. And we are developing this already now and updating our portfolio already. And of course, even include further security features here. This is clear. Yeah.
Great, thank you. Lubna, let's come back to you for a minute. We have a question on what are the improvements using Ignion's antenna solutions compared to traditional antenna designs for my asset tracking products?
Okay. For this question, I would answer the flexibility. The good thing is that our antennas can fit in all type of devices without the need of, let's say, design a specific antenna for the technology, for the application. So imagine you are designing an asset tracker and you have everything defined, and you don't have the space or the resources to create or to design an antenna. So by just integrating our antenna and tuning the signal to, in this case, GNSS, you will have the connectivity working. So the flexibility.
Okay, great. So you talked a bit about different technologies today. This question asks, can I cover multiple wireless standards with one antenna, or do I need to use separate antennas?
Yeah. Actually, with our portfolio, we have 6 antennas. So with our portfolio, we can cover as many configurations as configurations exist. So yes, we can cover with one of our antennas 3 technologies at the same time. Actually, the antenna is called Trio, and we can cover with the Trio LTE, GNSS, and Bluetooth with the same antenna.
Great. Let's see time here. Let me ask just one more question. Stefan, how can Telit support the architectures that were shown before?
Not they ask on these hosted or standalone architecture. No, it's of course we can offer support by our field engineers. They have experience of supporting hundreds of designs from telematic and tracking device providers among the recent years, from a schematic review till pre-certification. And in addition, Telit Cinterion offers a kind of a system integrator design house service to deliver complete turnkey solutions here. So this is called Telit Cinterion or Telit Solutions Services. So I hope this covers it, but of course the experience is here from decades, I would say.
Great. Yeah, and if you need any follow-up to that question, feel free to either add another question in here. We can get somebody to connect with you directly if we need to. I think we'll go ahead and wrap up there. If we did not get to your question, obviously, I will make sure that we get somebody in contact with you. Again, there were a few resources that were referenced today in the presentation that you can find in the resources section here. Please be sure to check your inboxes in the coming days for that replay link if you need. Stefan, Lubna, thank you guys so much for your time today. I really appreciate it.
Thank you.
Yeah, thanks, vice versa.
Thanks, guys.